Hello again. This week we're going to be working on graphing parabolas. That would be another Algebra 1 and Algebra 2 concept that we're going to be very important for our work in pre-calculus this year, so it's worth taking some time to review. So today we're going to be just looking at some vocabulary and basic parts of the picture, and then by the end of the week we'll be graphing these. Alright, so got a word bank up at the top. We're going to work through this together. It says standard form for a quadratic function is y equals, and then that would be ax squared plus bx plus c. So we've used that one. So that's a pretty important equation. Again, we're going to be using that one quite often. And again, it's got some pretty common things. The a, b, and c are constants. They are numbers that you won't actually see in the problems, but the x will always be there. All right, the shape of a quadratic equation is called a parabola. That's a parabola. Use that one. The next one doesn't have any words, but it's pointing to the imaginary line right up and down through the center of the picture, where if you folded it, the two sides would match. And again, that is called an axis of symmetry. It's not actually part of the graph or of the picture. It's just something that exists, and we use it to our advantage. All right, notice that there's a formula here for it. X equals negative b over 2a. We're going to be using that formula quite a bit this week. All right, next, again, no words, just pointing to a picture. Pointing to is this corner point right here at the bottom of the parabola, and that is called a vertex. Anytime something changes direction at a certain spot, it's usually called a corner or a vertex mathematically, and it has an xy coordinate. It's common and nice to know that that x-coordinate is the exact same answer that you get from the axis of symmetry. So when you do the x equals negative b over 2a, that happens to be the x-coordinate of your vertex. Then once you find that x-coordinate, what you actually do is plug that number back into the original equation and figure out what y is, because that original equation has been solved for y. All right, next, when the graph or the vertex is at the highest point on the graph, we call that a maximum. That would be the opposite picture that we have here, so it would be a graph that looks like this, where the vertex would be at the top of the graph. That would be an absolute maximum, the highest point on the entire graph. Then when the vertex is the lowest point on the graph, we call that a minimum, or in this case, it's an absolute minimum because it is the absolute lowest spot on the graph. There's nothing lower. Then our solutions, that's a special term we're going to be using, our solutions are the x-intercepts. All right, and those solutions have special names for quadratics. They are called the zeros. Whoa, can't write on there. The zeros or the roots. And again, the reason that they're called the zeros or the roots is because if you think about where the ground level will be, think about that as being ground level, ground zero. These spots right here, the x-intercepts, are the places where, like, trees have roots that go underground. That's what we call the underground part. So that's where the roots would start. Or we call them the zeros because that's the value where the height of the graph is at 0. And we use this particular type of equation, quadratic equations. We use them a lot for called projectile motion. Means anytime something goes up into the air and then back down to the ground, it follows the shape of a parabola. So again, it's very common for that. All right, so let's just do a couple of quick examples, because this is what your work looks like today. It's just taking some pictures that are already pre-drawn and identifying their parts. So it says, given the graph, identify the following. So first off, where's the axis of symmetry? Well, the axis of symmetry is an imaginary line that runs right through the middle of the graph. We want to know, where does it hit? Well, this one hits at x equals 3. Again, if I had an equation, I would be using x equals negative b over 2a, and that would tell me where that axis of symmetry is. Since I'm looking at a graph, I'm basically just looking for where it crosses the x-axis. It crosses the x-axis at 3. That's the middle. If you fold it on that number, on that spot, you'd get two matching sides. Next, the vertex. Well, the vertex is on the axis of symmetry, so it will have one matching thing. Now, what's the y-coordinate? Well, if you look over on this one and over to the side, the y-coordinate would be at negative 2. Next, how many zeros are there? So I see that this graph has crossed the x-axis twice. All right, where are those spots? Well, one of them is at 2, 0, and the other one is at 4, 0. That's where they are. All right, let's try one more. All right, this one says again, what is the equation of the axis of symmetry? So that's what we're going to do first. So again, the axis of symmetry is this imaginary line running up and down through the center. And this one happened to cross at x equals 2. All right, now where's the vertex? And then is it a maximum or a minimum? The vertex is up here. That vertex will be at 2, 4. Again, that matching x. And then this one would be a maximum because it's at the top of the graph. And then something that we didn't talk about in the other ones, but it's also very important when it comes to you graphing these yourself, is knowing where that y-intercept. Where does the graph cross the y-axis? And it looks like to me it's crossing down here at 0, -4. Seems to be where it's crossing. Maybe a little bit lower, maybe at -4.5 or even -5, but just use your best. Again, that's going to be hugely important when it comes to graphing these ourselves. All right, your work is relatively simple today, but hugely important vocabulary, so I hope you take your time to get it right. Good luck.